How will Mars sample return operate autonomously? Imagine sending a robotic team to Mars that can think and act on its own, without waiting for commands from Earth. That's exactly what the Mars sample return mission aims to do. This mission involves several spacecraft working together, all needing to operate independently because of the long communication delays. When it comes to collecting and returning Martian samples, autonomy is key. First, after the Perseverance rover collects rock and soil samples, a special lander called the Sample Retrieval Lander will deploy a fetch rover. This fetch rover is designed to find and pick up the sample tubes without human help. It uses onboard cameras and sensors to navigate the rocky terrain, identify the cache samples, and carefully pick them up. It can perform panoramic imaging to see its surroundings and analyze the samples in place. All of this happens with minimal input from Earth because signals take up to 20 minutes to travel one way. Once the fetch rover has gathered the samples, a small rocket called the Mars Ascent Vehicle will launch from the lander. This rocket is a two-stage system that will automatically ignite and place the sample container into orbit around Mars. This launch must be precise, and the vehicle needs to control itself during ascent, adjusting its trajectory if needed. This is a first for robotic missions and requires sophisticated autonomous control systems to succeed. In orbit, the Earth Return Orbiter, built by the European Space Agency, will detect the orbiting sample container. It will then perform an autonomous rendezvous, matching its speed and position to capture the container. Once captured, the orbiter will seal the sample in a special container called the Earth Entry Vehicle, which keeps the samples sterile and prevents contamination. The orbiter then prepares for the long journey back to Earth, managing all navigation and communication tasks on its own. Throughout all these steps, autonomous systems are essential because of the communication delay. The spacecraft relying on advanced robotics, sensors, and software algorithms to make decisions, navigate, and respond to unexpected situations. This independence allows the mission to operate smoothly and efficiently, maximizing the chance of success. When the Earth Entry Vehicle finally reaches Earth, recovery teams will be ready to retrieve the capsule and transport it to a secure facility for detailed study. The entire process depends on these autonomous operations to safely and accurately bring pristine Martian samples back home. In short, the Mars Sample Return mission will operate autonomously by using smart robots, precise onboard control, and advanced navigation systems. These technologies work together to handle everything from sample collection to orbital rendezvous and return, all while overcoming the challenge of communication delays. This approach ensures the mission's success and opens new doors for future space exploration.